Okay, this is our January 26th, 2021 lesson, virtual learning day for Bologna High School Recalculus class. We're going to do lesson 1.6, transformations, where today we're going to look at vertical and horizontal translations. And translation is just a shift. So horizontal translation is takes a function, takes the graph of a function. Remember, the graph of a function is the set of solutions. It's a visual representation of every point, x and y, that go together. So when you plug the x and y in the equation for f of x, then you get the equation is true. So the graph of a function, every point on the graph has an x and a y coordinate, and when you plug in that x and y to the equation for this function f of x, it makes the equation true. So each point on the graph is a solution. A translation takes every point on the graph of that function and shifts it. It moves it either to the left or the right or to up or down. Horizontal translations move left and right. Vertical translations move up and down. So if we were going to take and make g of x, some function g of x, a horizontal translation of f of x, say 2 units right, then every point on the graph of this function would move from where it's at 2 units to the right. So this point at 0, 0 would move to the point 2, 0. This point at 1, 1 would move to the point 3, 1. This point at negative 1, 1 would move to the point 1, 1. And every point along this graph would also move with it. So the new function, g of x, would be shifted 2 units to the right. If we let this graph be f of x, then we make g of x a vertical translation of f of x. Let's say 2 units up. Then under this translation, under this shift, takes every point on the graph of f of x and moves it up 2 units. So the point 0, 2, or 0, 0 would move to the point 0, 2. The point negative 1, 1, negative 1 would move to the point negative 1, 1. The point negative 1, negative 1 would move to the point 1, 1. And all the points along the curve would move with it. So the graph of the new function, the transformed function, the translated function, would look like that. So under these translations, every point on the curve, if I told you that there's a single point, you don't know what f of x is. But if I told you that f of 3 equals 5, it's not for this function. As a matter of fact, I'm going to erase this function. Let's say that I told you that f of 3 equals 5, and to name a point, or find a point, that must be on the graph of g of x. When you know f of 3 equals 5, that means if you plugged in 3 for the equation for f of x, you would get 5 for the y value. This is the x value, and this is the y value of a point that's a solution to the function f of x. So I know the point 3, 5 is on the graph. And g of x shifts this function 2 units to the right. The point 3, 5 is going to move 2 units to the right. If it moves 2 units to the right, it's going to become the point 5, 5. So if we're shifting 2 units to the right, if you have a point xy on the graph of the function, and if you shift it 2 units to the right, it's going to add 2 units to the x-coordinate. So you're going to get whatever the x-coordinate was plus 2, and then the y value is going to stay the same because under a horizontal translation, the y value doesn't change. If we're going to take, and let's say we have a function f of x, and let's say f of -1 equals 4. If we're going to shift that function 2.2 units up, we're going to find a point that must be on the graph of g of x. For this translation here, a vertical translation of f of x 2 units up to get g of x. If I look at this on the graph again, and I take the point -1, 4, and I want to shift that 2 units up, then the point's going to move. The x value is not going to change. This is going to become the point -1, 2 units up from 4 is 6. So under a translation, a vertical translation 2 units up, the point xy on the curve becomes the point x. Vertical translation doesn't change the x coordinate. And the y value, you just add how far you move up, or subtract if you were going down. Here, if you were changing the point, you would subtract if you were going left. So those are the ways I'm going to ask you questions. Well, there's 2 of the ways I'm going to ask you questions. But we're going to do it a little different. What I want you to see, we'll talk about horizontal translations first, that if you have a function g of x that's equal to f of x minus h. So what this means is if I take the function x and I replace it with, the function f of x, and I replace the x with x minus h, this shifts the graph of g of x h units to the right. So if this is true, then g of x is a horizontal translation of f of x h units to the right. And this seems counterintuitive because we think if we were shifting this to the right, we would plug in x plus h. But when we're operating these functions, if you want to shift the function h units to the right, you replace the x in the function with x minus h. And that's what this is telling you. So let's look at an example. If I have the function f of x equals x squared plus 2x minus 1. If you have your calculator at home, go ahead and graph that on your calculator. If you don't have your calculator at home and you're looking at this on a computer or your phone, go to Desmos, search Google Desmos graphing calculator. Go there, enter this function in your graphing calculator on the Desmos, so you can look at the graph. If I said g of x is a horizontal translation of this function, let's say 3 units left, 3 units to the right, whatever. Then that tells me, based on what I just showed you up here, and you're going to verify this on your graph, g of x is equal to f of x minus 3. If I shift, if h becomes 3, I'm shifting 3 units to the right. I replace the x in f of x with x minus 3. If I replace this x in f of x with x minus 3, I have to replace every x in the function with x minus 3. So I had an x squared, now I have an x minus 3 squared. I had a 2x, now I have a 2 times x minus 3. I still have my minus 1 because all I'm doing is replacing the x with x minus 3. If I want to expand this, because on your test you'll see this is multiplied out in a standard polynomial form, I'm going to multiply. Remember, this is not x squared plus 9. This is x minus 3 times x minus 3. This, of course, we just use the distributive property, get 2 times x minus 6 minus 1. We're gonna clean this up, I'm gonna multiply this out and get x squared minus 3x plus minus 3x makes minus 6x. And negative 3 times negative 3 makes plus 9. This is plus 2x. And this becomes negative 7. So all together we get x squared minus 6x plus 2x makes minus 4x. Plus 9 minus 7 makes plus 2. So what we're saying is that g of x is a shift, a translation of f of x, this function f of x, 3 units to the right. If you graph this in your graphing calculator, either in Y2 on your calculator or in a second function line there on Desmos, then you should see that this graph is actually just a shift. Took every point on the graph of f of x and moved it 2 units to the right. I will ask you, give you a function like this, tell you a translation of g of x, and ask you to find the equation for g of x, or the function for g of x. And this is what you would do. You would plug in the x minus 3 if it was a shift 3 units to the right. You would simplify that and match it with the answer on the test. You'll also have to recognize, if I told you that f of 1 equals 7, and g of x equals f of x minus 5. You need to recognize that g of x is a translation 5 units to the right of f of x. So you know, this tells you the point 1, 7 is on the graph of f of x. Oh, I'm going to ask you here. I'm going to ask you to find a point that must be on the graph of g of x. And all you know here, you don't know what the function f of x is. All you know is one single point on the graph of f of x. Excuse me. So we figure out what that point is on f of x. If we look at this graphically, you don't have to graph it, but if it helps you. If we start with point 1, 7, we know this is a shift 5 units to the right. The x-coordinate 1 is going to shift 5 units to the right to become 6. So the new point on the graph of g of x is going to be the point 1, 6. Or sorry, 6, 7, sorry. So the point 6, 7 is the answer. Since that's the only point you know on f of x, that's the only point you can find on g of x. Has to be the answer. I may tell you that there's an arbitrary point. On f of x. I could say that f of a equals b, and you don't know what a and b are. Oh, should have looked at this. Find a point on g of x. It must be on g of x. This tells you the point AB is on f of x. And so, we don't know what a and b are. We can let it be anything to give us an illustration of this. If we're going to move this 5 units to the right, because that's a 5 units to the right translation, then we're going to move the x-coordinate 5 units to the right. So we're going to move a plus 5. The new point is going to be point a plus 5. The y-coordinate stays the same under a horizontal translation. So the new point is a plus 5 b. And that's all we can tell because this is all we're given about the function f of x. And we know that g of x is a translation 5 units to the right. Those are the ways I'll ask you questions about translations. So now that we've done translations to the right, it should probably make sense to you that we will do translations to the left. We use the same function here. First, instead of writing out a big long sentence every time, I'm going to kind of abbreviate this note. So, we're going to say, when g of x equals f of x minus h, g of x is a horizontal translation of f of x, h units right. I'm going to do this. We may call it a different function because I may not remember that one. If g of x equals f of x plus h, you might already see where this is going, then g of x is a horizontal translation of f of x. This time, h units left. Again, you would expect when you replace x minus x with x minus h to shift to the left, and you would expect when you replace x with x plus h to the right, but it does exactly the opposite. What I like to tell students is that when you're doing transformations, when you change the inside of the function, and by inside I mean when you replace x with something, it does the opposite. It behaves the opposite of what you would expect. So when I replace it with x minus h, instead of shifting to the left h units, it shifts to the right. When I replace x with x plus h, instead of shifting to the right h units, it shifts it to the left. I'm going to check and make sure my recording's on because it cut off on me yesterday. Yes, we're still recording. That's good. We may as well go ahead and lay out the rules for vertical translations also while we're up here. So if g of x, this time, I call this changing the inside of the function. We'll replace x with something in the function. This time, if we have f of x, didn't replace x with anything. We still have the original function f of x, and we add, let's put k out here. There are reasons for this. We need to study other math. All right. If g of x equals f of x plus k, where the f of x didn't change, whatever the f of x was, it stays the same, and now just add the constant k to it. Then we say g of x, and this actually is a vertical translation of f of x, k units, wait for it, up. One thing you need to recognize with transformations, what tends to happen when you change the inside of a function, this will happen later when we do stretches and compressions also. The function behaves the opposite of what you would expect. When you change the outside of a function, this is what I say, we're changing the outside of a function. We don't replace x with anything. Sorry. We add some constant or subtract some constant from the outside. We change outside the function, then this is a vertical. It affects the y coordinate of the function, of the graph. So if we have g of x equals f of x, and then add a constant to f of x, we get g of x as a vertical translation of f of x, k units up. It behaves the way you would expect when you're doing vertical transformations. G of x, if g of x is f of x minus k, then you're probably already seeing this, like I told you before, math teaches itself. G of x is a vertical translation of f of x. This time, k units down. So let's put these into play with a couple of examples. And let's say let f of x equal, let's do our function we did a minute ago, x squared plus 2x minus 1. And I'm going to tell you to find g of x if g of x equals f of x minus 2. Oh, we did that one already. Let's do x plus 2. I'm going to tell you to find g of x if g of x is equal to f of x plus 2. And I'm going to tell you to find g of x if g of x equals f of x minus 2. Or, if I didn't ask you for this, because you recognize this is a shift to the left 2 units, translation to the left 2 units, I could have said, not giving you this, and said find g of x if g of x is a shift left 2 units. Here, I could have said find g of x if g of x is a shift, remember we add on the outside, up 2 units. And here, I could have said find g of x if g of x is a shift down 2 units. We want to find g of x here for a shift left 2 units. We know that g of x equals f of x plus 2. So we take our f of x, this f of x, and replace the x with x plus 2. So instead of having x squared, we have x plus 2 squared. Instead of having plus 2x, we have 2 times x plus 2. And then we still have our minus 1 tagging along with it. X plus 2 squared, remember, is x plus 2 times x plus 2. This becomes 2x plus 4 minus 1. X plus 2 squared, x plus 2 times x plus 2, becomes x squared. 2x plus 2x makes 4x. 2 times 2 makes 4. This is going to be plus 3. Now I combine like terms. I get x squared plus 6x plus 7. Verify in your calculators. Graph f of x and graph g of x and see that this is just a shift of this function 2 units to the left. If we want to shift it up 2 units, we take the function f of x and we just add 2 to it. This is a little easier than the horizontal. F of x was x squared plus 2x minus 1. We replace this part. Now all we do is add 2 to the function, and we simplify that, and we get x squared plus 2x plus 1. That took this function, f of x, and shifted it up 2 units. If we want to shift it down 2 units, we take g of x is equal to the original function minus 2. So that is x squared plus 2x minus 1. Then we subtract 2 from that. Simplify, we get x squared plus 2x minus 3. If I give you a function f of x and tell you that g of x is some horizontal shift or vertical shift, then you have to be able to apply this rule, this rule, this rule, or the rule to shift to the right, based on the translation that I give you. And you have to be able to plug in whatever it is you have to plug in and find the new function, the translated function. If I told you, given, let's say, f of 3 equals negative 2. And I said find a point that must be on the graph of g of x if, let's say, g of x equals f of x plus 5, or if g of x equals f of x minus 5, or if g of x equals f of x plus 5, running on a ring. Or if g of x equals f of x minus 5. Here, we know the function. This is a shift. This tells me that this is a translation. 5 units left. If I look at the point I'm giving the point 3, -2 is on the graph. That looks like 3, that looks like -2. If I want to shift that 5 units to the left, if I go 3 units to the left, I'm at the y-axis. If I go 2 more units to the left to make 5 units to the left, I'm at -2. So this point moving 5 units to the left becomes the point -2, -2. Here, this is a translation, 5 units right. I've got the point 3, -2. I'm sorry. Yeah, that's -2. I erased it. 3, -2. I want to shift it 5 units to the right. I'm going 5 units this direction. That's going to take the point to 8, -2. Doesn't change the y value, right? Doesn't change the y value, correct. If you can see the math, you can do the math. If you plot the point, then apply the transformation, it's a lot easier to get it right. This one, running out of room, so I'm going to do this here, is a shift 5 units up. So I'm going to take the point 3, -2. If I go 2 units up, I'm back at the x-axis, so I got to go 3 more to make 5. So that's going to put me at the point 3, 3. This one is a shift 5. Oops, that was supposed to be on the outside. F of x minus 5. We already did the x minus 5 on the inside here. So if I'm going to shift this one is a shift 5 units down. So if I'm going to take the point 3, -2 and shift it 5 units down, it's going to go to the point 3, -7. That's your lesson on vertical and horizontal translations. You should have taken a pre-test before you started this. Now you'll take the exit ticket that's on Edge Elastic, and then you will do the homework assignment. And then you'll be finishing at your virtual assignment for January 26th, 2021, Virtual Learning Day.